Hi, what is the value of x? Given that you have open parenthesis x minus 1, close the parenthesis to the power of 6 equals 64. Then let's have it to be solution. So from here we have x minus 1 in parenthesis to the power of 6 equals 64. But let us recall that when we have a to the power of m equals b to the power of n, so far they have the same power, we can equate the base, so therefore a will be equals b. So from here, let us recall that we can have 64 to be equals 2 to the power of 6. So therefore from here we have x minus 1 in parenthesis to the power of 6 equals 2 to the power of 6. So far they have the same power, we can equate the base, and so therefore we have x minus 1 to be equals 2. So from here we have x to be equals 2 plus 1, which equals 3. So finally we can declare that our x equals 3 is the first only solution. But I must tell you that x equals 3 is not the only solution for the problem given to us. Then let's see how to solve it. Let's recall from here we have x minus 1 in parenthesis to the power of 6 equals 2 to the power of 6. Then let's rewrite this power 6. We can have 6 as the product of 3 times 2. So from here we have x minus 1 in parenthesis to the power of 3 times 2 equals 2 to the power of 3 times 2. Then let's take this term to here. So we have x minus 1 in parenthesis to the power of 3 times 2 minus 2 to the power of 3 times 2. Then let's set everything to be equal to 0. So from here, recall that when we have a to the power of m times n, we can rewrite this as a to the power of m in parenthesis to the power of n. So this implies from here we have x minus 1 in parenthesis to the power of 3. We close it as this to the power of 2. Then minus 2 to the power of 3. We close it as this to the power of 2 equals 0. Then when we consider the power, it looks, or it goes with difference of 2 square, because this one has power 2, this one has power 2. Recall that when we have a square minus b square, we can simplify this a plus b, then multiply by a minus b from the algebraic expression. So from here we have x minus 1 in parenthesis to the power of 3 plus 2 to the power of 3. We have it as this. Then again multiply by x minus 1 in parenthesis to the power of 3 minus 2 to the power of 3 as this. Then we still have everything to be equal to 0. Then what are we saying is that for this expression to be equal to 0 is either we have x minus 1 in parenthesis to the power of 3 plus 2 to the power of 3 equals 0, or we have x minus 1 in parenthesis to the power of 3 minus 2 to the power of 3 equals 0. Then let's solve this one after the other. Let's say we have case 1. This one has to do with the sum of 2 cubes. Recall that when we have a to the power of 3 plus b to the power of 3 always equals as a plus b in parenthesis multiplied by a square minus ab plus b square. With this one, we discover that our a equals x minus 1, then our b equals 2. So when we substitute it here, we are going to have x minus 1 plus 2. So multiply by x minus 1 in parenthesis to the power of 2 minus x minus 1, b is 2 plus 2 square equals 0. So from here we have x minus 1 plus 2 will give us plus 1 as this. The expansion of this will give us x squared minus 2x plus 1. When you open the bracket with minus from here, this will also be minus 2x, then plus 2, then this will give us plus 4 equals 0. So from here we have x plus 1, this minus 2x minus 2x. From here we have x squared minus 4x, 1 plus 2 will give us 3, plus 4 will give us 7 equals 0. Now for this term to be equal 0, it's either we have x plus 1 equals 0, or we have x squared minus 4x plus 7 to be equal 0. So from here we have x to be equals minus 1. This is another second row solution for the problem. Then from here we can apply the quadratic formula to get the value of a from the value of x from here. X will be minus b, positive or negative, square root of b squared minus 4ac divided by 2a, where the parameter a is the coefficient of x squared, which is 1, parameter b is the coefficient of x, which is minus 4, and c equals 7. So from here we have x to be equals minus into minus 4, positive or negative, root of minus 4, to the power of 2, minus 4 into bracket of a is 1, then c is 7, divided by 2 times 1. So from here we have x, minus times minus will be plus 4, positive or negative, root of this will be 16, minus 4 times 7 will give us 28, divided by 2. So this will be equals 4, positive or negative, root of 16 minus 28, we have it to be minus 12. Divided by 2. So from here we have root of minus a equals as root a multiplied by root of minus 1, but root of minus 1 equals I, so therefore this will be root of a multiplied by I. So this will now be x equals 4, positive or negative, root 4 times 3 multiplied by root of minus 1, all divided by 2. So we have x 4, positive or negative, root 4 is 2, multiplied by root 3, root of minus 1 is I, divided by 2. So when we divide 2 by 2, this will be 4 divided by 2, positive or negative 2, root 3i divided by 2. So we have this to be 2, positive or negative, this will cancel out this, we have root 3i. So therefore x equals minus 1, 2, positive or negative, root 3i for the first solution. Then let's take a look at the case 2, where we have x minus 1 in parentheses to the power of 3 minus 2 to the power of 3 equals 0. Recall that this goes with when we have difference of 2 keep, when we have a to the power of 3 minus b to the power of 3 equals as a minus b in parentheses multiplied by a square plus ab plus b square. So from here we are going to have this to be x minus 1, then minus b is 2, as this multiplied by x minus 1 in parentheses to the power of 2 into x minus 1 multiplied by 2 plus 2 square equals 0 from here. So from here we have x minus 3, minus 1 minus 2 will be minus 3. The expansion of this will be x squared minus 2x plus 1. When you open the bracket with 2, from here we have plus 2x minus 2 plus 4 equals 0. So from here we have x minus 3 This minus 2x plus 2x we cancel out. We have x squared. This minus 2 plus this one will give us 3. 2 plus 1 will give us plus 3 from here equals 0. Then for this expression to be equal 0, it's either we have x minus 3 equals 0 or we have x squared plus 3 equals 0. And so therefore we have x to be equals 3. This justifies the second solution. The previous solution, sorry. From here x will be equals positive or negative root of minus 3i minus 3 root of minus 3, and x will be equals positive or negative root of 3i. So from here we also have another solution for the x to be 3 comma positive or negative root 3i. So this is another solution for the problem given to us. So if you want to check, we can verify this. Let us recall that we are given x minus 1 in parentheses to the power of 6, which equals 64. When x equals minus 1 and x equals 3, let's verify for the real solution. So from here we have x minus 1 to the power of 6, then it's going to give us 64. Minus 1 will give us minus 2 in parentheses to the power of 6, then it's going to give us 64. When you have minus a in parentheses to the power of even number, this equals as plus a to the power of even. So from here we have 2 to the power of 6, which equals 64. Likewise, when x equals 3, here will be 3 minus 1 to the power of 6, so going to give us 64. 3 minus 1 will be 2 to the power of 6, which equals 64. So seeing the left hand side equals to the right hand side, x equals minus 1, x equals 3, satisfy the problem given to us.